We'll talk about the chemistry of these three major classes of macronutrients, starting with fats and oils. Every day, fats and oils, so olive oil, the butter, but also cheeses and milk, and soft cheeses like cream cheese. And these are properties of these fats that you'll recognize that they all have in common is that they're greasy, they're slippery, they're soft, they have a low melting point, which is why some can be solids at room temperature, but others can be liquids at room temperature. When there's a melting point that's equal to room temperature, then it'll be a liquid instead of a solid. These are also not soluble with water, so oil and water don't mix because they tend to be nonpolar compounds. So they are not soluble or water insoluble solids or even liquids. So these foods, including fats and oils in foods like fats and oils in meat and fish, they're sources of the fats and oils that are animal origins, but there are also fats and oils in vegetable. So vegetable origin like corn oil, or peanut oil, or nuts themselves are loaded with fats and oils. Fats and oils are in our food, and they give food desirable flavor, texture, mouthfeel, and they can come from animals or vegetables. Fats in general are solids at room temperature, and oils are liquid at room temperature. Both fats and oils are in a class of compounds that are called lipids. So this is showing the lipids, and you can break it down into triglycerides, which include the fats, the solids at room temperature, or the oils that are liquids at room temperature. Those are called triglycerides because of the chemical structures that we'll look at. The other types of lipids are also common, but not in foods. So beeswax and steroids, these are also lipids, and what they all have in common is that they have a lot of carbons and hydrogens. They're not only hydrocarbons, but they are, in general, a lot of carbons and hydrogens compared to the other macromolecules. Triglycerides that are formed from three, that's the tri, fatty acids, so 3 fatty acids, and 1 glycerol molecule. So this is the structure of the glycerol molecule. Glycerol is 3 carbons with 3 OH groups. That's the hydroxide group that is the hydroxide polyatomic ion. So there's 3 carbons with 3 hydroxides, and then the rest are hydrogens. So this is 1 glycerol molecule. And then you'll add on 3 fatty acids through these hydroxides. The fatty acids, these molecules we'll look at on the next slide, but these fatty acids can either be saturated fat or unsaturated fat.
We're going to be looking at structures of organic molecules. Organic molecules are carbon-containing molecules. And so this is a whole branch of chemistry. We'll get more into this in chapter 12 as well. But this is the glycerol molecule shown here. And the glycerol molecule has 3 carbons, 1, 2, 3 carbons, and 3 hydroxides, 1, 2, 3. So that OH group is the hydroxide group. And you'll notice that every carbon has exactly 4 bonds. And this can be in a combination of 4 single bonds, 1, 2, 3, 4. Or there can be double bonds and triple bonds. So you can have 4 single bonds like this, 1, 2, 3, 4. Or a double bond, which would then lead to 2 single bonds. Or a triple bond, which would then lead to 1 single bond. So there has to be a total of 4 bonds coming out of the carbon atom, and it can be single, double, or triple, but it has to add up to a total of 4 bonds. So there are 4 bonds coming out of this carbon on the left, this carbon in the center, and this carbon on the right, and that's true of every carbon in every organic molecule. And this becomes important in looking at what's called the line angle drawing. So the line angle drawing represents the carbon atoms are at line intersections or at the end of the line. So at the end of the line or where 2 lines connect. Okay, so this would be an example of a carbon atom at this intersection, or this carbon atom at this intersection, or this carbon atom at that intersection. And these are equivalent to these carbon atoms. So this carbon atom here is equivalent to this carbon atom here that has 4 bonds coming out of it. One bond is to an OH group, so that's this OH group, and then one bond is connected to the rest of the molecule, which is this other carbon. So there's no C that needs to be drawn, and that's a shortcut version. And the other is that the hydrogen atoms, I'll do those in green, are implied. So the hydrogen atoms, and so this means that there are no hydrogen atoms shown here, but there are 2 hydrogen atoms that are implied in this molecule that would be bonded here. And so this is a shortcut version that allows not having to draw any of the carbons or any of the hydrogens, and this becomes important when you're drawing molecules that are more complicated, that have a lot more carbons and hydrogens. The ball and stick model is the best representation, which shows the 3 carbons of the glycerol molecule and then the 3 OH groups. And the 3 OH groups are bonded up, down, and up, which is the most symmetrical arrangement, which nature prefers symmetry. But this shows the colors, where the carbons are the black atoms, the oxygens are the red, and the hydrogens are white. And so when you have a more complicated molecule that has more carbons and hydrogens, so this is a saturated fatty acid. Saturated fatty acids have all single bonds. So these are all single bonds between the carbons. And this is best shown here in the ball and stick model, where you have, these are the carbon atoms, the black atoms, and these are just single bonds connecting those, okay? And each of these in the center section, each of these carbon atoms is a carbon with 2 hydrogens. So each of these is equivalent to CH2. Okay, so this is CH2, this is CH2, this is CH2, and so on. So the carbons at the end, this carbon at this end, is a carbon with 1, 2, 3 hydrogens. So this is a CH3 group. And then this carbon on this end, in green, is a carbon that has a double bond to an oxygen and a single bond to an OH. So this looks like this, is a carbon with a double bond to an oxygen and a single bond to an OH. Or we could just write it for short, COOH. This is called a carboxylic acid group, this COOH, and it is a carbon with oxygen and OH. So how this looks on the line angle drawing, though, is a lot quicker to draw. This zigzag line, these are a bunch of CH2 groups. How many of them are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So there's 16 of those CH2 groups. And then this is a CH3 group at the end, so I'll draw this. And this is just having the carbon at the end. All you have to do is draw a dot or just have the end of the line. And this on the other end is this COOH group, which you would write out COOH. Okay, but the line angle drawing is the quickest way to draw these molecules that have a lot more atoms in there.
Fatty acids can be saturated fats or unsaturated fats. And saturated fats or saturated fatty acids have all single bonds. So those are single bonds between the carbons, and so it looks like this, where you just have this zigzag line, all single bonds. Now this is accepting this carbon at the end, which is what's called carboxylic acid group. It's the carbon double bond oxygen OH group. It is one of a family of what we'll talk about in the next chapter, which is called functional groups. So this is a carboxylic acid group. It's COOH. Unsaturated fatty acids, just focusing on this tail of the fatty acid. So unsaturated fatty acids have at least one double bond. So you can have a monounsaturated fatty acid. A monounsaturated fatty acid has one double bond. So this is shown with an extra bond here, okay? And this is a monounsaturated fatty acid, oleic acid. This is the major fat that's in olive oil. Then you can also have a polyunsaturated fatty acid. Polyunsaturated fatty acids have two or more double bonds. So this is showing linoleic acid with two double bonds on that fatty acid tail there. And linolenic acid, this has three double bonds. Now both linolenic and linoleic acid we'll talk about in terms of healthy fats, which all of these, the monounsaturated, the polyunsaturated, these all tend to be healthier than saturated fats. From the structure, the saturated fat is just this straight chain fatty acid tail. And when you have straight chains, these tend to stack up. So what happens on the macro level is that saturated fats are straight chains that can stack up and become solid at room temperature. Or, in general, they can stack up in the arteries and lead to plaque formation, which is an unhealthy fat. These monounsaturated and polyunsaturated fats having a double bond leads to a bent overall structure. So bent for monounsaturated and even more bent for the polyunsaturated structures. And so the bent structure does not allow for these unsaturated fats to stack up. So therefore these are called healthy fats. They can't stack up, and therefore they are liquids at room temperatures. These molecules will flow over each other, and they also don't stack up in the arteries and tend to be healthy fats. And so that's the case if you've heard of olive oil being healthy, or the Mediterranean diet. That's because the major fatty acid in olive oil is oleic acid, which is this monounsaturated fatty acid that has one double bond, doesn't stack up, it's a liquid at room temperature.